So hi, I'm Charles Goddard. I'm a senior research engineer at IIA, and I'm also the author of a open source toolkit for model merging called MergeKit, which is very creative, I know. And I'm here to talk about the concept of model merging, what it is, why you should be doing it, and how you can get started doing it. So model merging is a technique that lets us take two or more trained neural network models and combine them into one model that combines the strengths and qualities of all the models that you're putting into it. It's also not ensembling. Ensembling is a related technique. It's a great technique that I love, but it involves inferencing a bunch of different models and then combining their answers into a new, better answer, versus model merging produces a single model that's not any bigger than the models that you put in to get in the first place. So it's the same cost as inferencing a single model. And it involves no training. There's no GPU or expensive compute needed. You can do it on a CPU. Model merging is useful for a lot of things. One of my favorite things about model merging is that it's a great sidestep to the problem of catastrophic forgetting. So you can, for example, take a language model, train it on a whole bunch of data that you care about, and the end result is a model that's really, really good at the tasks involved with that data specifically, but frankly garbage at everything else. With model merging, you can take that checkpoint and you can merge it in with some other more generally capable model and get something that has the strengths of both. So it's really good at your domain-specific task, and it still has general instruction following capabilities and general intelligence. It's also a great way to make more powerful models than you could otherwise for essentially free. One of the common uses for model merging in literature is to take a bunch of models that are trained on the same task, maybe even on the same data, and merge them together into one model, and you get something that it essentially acts as a really good regularization. You get better performance than any of the models that you put in there, and better generalization to out-of-domain data. And you can also do this with models trained on different tasks. And the result, sometimes when you're lucky, is that these models will synergize in a way that gives you a model that's better on your input tasks than any of the models that you put into the process. And it is also a great way to just take advantage of the really rich open source ecosystem of models that's available today. Just pick the pieces that you want, combine them together to make something that's perfectly tailored for your use case while not doing a single bit of training yourself. Some specific use cases, for examples. One of the things that RC, the company I work for, does is we do accelerated continued pre-training of language models. So the specific use case that we attend to is these customers who have large piles of proprietary data that they want to work with a language model, but for whatever reason don't want to upload to OpenAI or public clouds. So we do continued pre-training using their data on base models, then use open source releases to merge back in cutting edge instruction following capabilities for, like I said, essentially free. Another great property of model merging is that it makes the models that you train useful for a lot longer. It turns them from these instantly depreciating assets into something that you can sort of carry forward with you. So we spend all of this time and all these resources and all of this effort producing models fine-tuned for our use cases. And the inevitable thing that happens is a week after you finish training your model, someone on the internet posts something that blows yours out of the water. Your model doesn't have to stop being useful there. You can take that checkpoint you trained, merge it in with whatever the new hot thing is, and get all of the latest research advancements while still keeping that model useful that you've spent all that money on. And it's also just a great way to hyper-personalize a model to exactly what you want using open source components, as I mentioned. All of model merging is basically built off of the assumption of linear mode connectivity. This is a property such that for two neural network models, if you draw a line in parameter space between the models, any of those points is actually a valid model and will have essentially the same loss on your data. This ends up being the case for basically any case where you're fine-tuning a pre-trained foundation model, for example. So speak to language models precisely. If you take a Mistral 7 billion parameter model, do a fine-tune of it, then it will be linearly mode connected with any model that was trained off of Mistral 7b. So that's basically guaranteed to work anything in that sort of same architecture situation. So all of the techniques built in this field are essentially fancy versions of interpolating parameters. They get a lot fancier than that, but that's the foundation of all of this. So the most popular techniques in use today, these are the ones that show the most use. I'm not going to go into too much detail on any of these, but I'll quickly flip through them. Linear merging is a very fancy name for just averaging the weights. You just take a pile of models, you average all the parameters, and the result somehow works better than any of your inputs. It sounds stupid, but it's ridiculous how well it works. And it's sort of the baseline for all model merging methods. It's what everything's compared against. Slurp is actually just the Ken Shoemaker algorithm from the 80s. It's just interpolating in spherical space instead of linear space, and for some reason it works better than linear. Task arithmetic is a whole family. Well, task arithmetic is a specific method, but it's also spawned a whole family of related methods. These are actually my favorite methods. I could go into a lot of detail here, but I don't think there's quite the time for it. So I'll just say that it's also just a very useful mental framework for thinking about merging with multitask scenarios. So if you want to read some papers, this is a great place to look. Model stock is a very recent technique. The paper is a couple of weeks old, and basically the researchers who wrote this paper, it's a great paper, by the way, they did a lot of really good analysis, found some interesting geometric properties. Basically, when you fine-tune a whole bunch of models on similar data, they form a thin shell in weight space around sort of a center, and they use some geometry tricks to approximate that center using only a few models. So if you're a paper reading kind of person, also highly recommended. This is a great paper. And finally, there's path-through merging, which is kind of a merge kit innovation. It involves basically taking layers arbitrarily from models and combining them to form a new model that's a different size from any of the parts that you put in, kind of like making a demented sandwich from inappropriate components. This is what's been used to make a lot of weird size models that you may have seen in the language model community, like Goliath 120 billion is a model that was assembled from stitching together a couple of 70 billion parameter models. And it's also the technique behind Solar's, Upstage's Solar model. They extended Mistral and did some continued pre-training on top of that. It's also sort of in a similar family to the Llama Pro paper, if you're familiar with that. So that's a whole bunch of talking about the actual methods. How can you actually do this? MergeKit is kind of the best way to get started with actually merging models. So MergeKit is completely open source and free to use. It's available on GitHub there. And it implements all the methods I've talked about here and a whole bunch more as well. It's really easy to use. You just have to write a YAML configuration file and throw it in there and you'll get a model out. And like I mentioned earlier, it does not require any GPUs or any fancy hardware. You can run this on a 10-year-old laptop. You can run this on a full node of GPUs if you want. It's very, very low resource. It's just an example of a configuration file to show what I'm talking about. You just list the models that you want to be merging, and there are some parameters for some of the methods. There's documentation on the GitHub. Oh yes, and also recently in partnership with Hugging Face, we've released a space on the Hugging Face hub where you can just type your YAML files into this online and run it online, and it'll push it right to the hub. So you don't even have to have a 10-year-old laptop if you want to play with this. You can get started right now by going to this URL and checking it out. So model merging is kind of what I do. I'm always researching new stuff. Some of the stuff that I'm excited about that's coming up is cross-initialization merging. So like I said, all these techniques are built atop of the assumption of linear mode connectivity, which is a property that's basically guaranteed to hold for fine-tunes of the same model. But if you want to merge something like a Llama model with a Quent model or a Mistral with a deep sea coder, for example, you're kind of currently out of luck because that property does not hold. That's a thing that's I'm continually working on, and sometime soon I'm going to crack that, and you're going to be able to do that kind of merge. If you're familiar with the field of model merging, you've probably read Sakana AI's recent paper on evolutionary algorithms for model merging. It got a lot of attention recently. There's an implementation of that paper, which is going to be coming to MergeKit sometimes next week, probably Monday. So I'm really excited to see what the community does when they get their hands on that. It should be a lot of fun for people to play with. And of course, there's always the dream of merging completely different architectures, like a vision model with a language model, or even the more pedestrian merging encoder-decoder models with similar, but yeah, I think that's fairly self-explanatory. So if there's time for questions, I'm happy to answer any, but otherwise I'll be around, so feel free to hunt me down and ask me anything anything you'd like. Thanks for listening to my talk.